Okay, so Quadratics 11. Here's the title. Comparing linear, quadratic, and exponential functions. All right, and to do this, go on, I guess I do need your Chromebook screen up. Go on your Chromebook to Desmos.com. So open a tab and go to Desmos.com, because we're just going to do it on Desmos, right? You don't have to graph these by hand. Go to Desmos, please. Please go to Desmos. Please and thank you. Please, are you going to Desmos? Okay, that's fine. This one's yours, but that's fine. You can do it too. Are you going to Desmos? Go to Desmos, go to Desmos. Are you going to Desmos? All right, so let's go ahead and let's do the examples first, and then we'll go back and map it out. I want to know let's try it first. Linear, quadratic, and exponential. Here's our three that we're going to compare. We could do more, but this will be enough. Exponential. All right. What shape of graph will a linear function produce? Nice. Okay, draw it in the air with your finger. Okay? Sometimes I feel like, I had a student the other day in one of my other classes doing some things. I think they were just messing with me because I was trying to figure out what they were drawing. But I see several of them. Andrea, what did you draw? She's motioning like this, and that's fine. We can do it silent. I'm game with that too, right? Was that what you were doing? Right? What you want to say it out? Who wants to say it out loud? What will you have? A picture of what? A line. Okay, everybody say line. Okay. Quadratic now changes. You've been dealing with them for 11 lessons. Will you start to warm up your brain and think about the graph that a quadratic produces and draw it in the air. Draw it in the air. Good. Draw it in the air. What graph does a quadratic produce? I would like by now for you to know this. If not, at the end of this, how about at the end of this lesson? If you don't know it right now, by the end I want you to know this. Fair enough? Okay, draw it in the air. Yes. Kind of like this? Yes. What shape does it look like? A U. Everybody say U. But that's not the name of it. You need to know the name of it. It is? Parabola. Everybody say parabola. Right? You need to know that. Go to your next teacher in Algebra 2 and they say it's a quadratic. What shape does it make? If you say parabola, you're already down the road with your next teacher, right? Which might be, depending what school you're in, it might be Dr. Shi or Miss Leone, or I kind of forget who our Algebra 2 teachers are. You with me? So you'll cover a lot of parabolas in that next algebra class, right? Do you know exponential? Yeah, very good. I see one. Can you draw exponential in the air? What's your big example of exponential that's been affecting us all for the last 2 years? And for the first time, I'm not even wearing a mask in class, right? What's your big example of an exponential graph? Draw it in there. Can you draw the exponential curve? Okay. I mean, pretty good. Pretty good, right? Well, let's go ahead and graph them. Here's your first example to type in. You have Desmos open. Let's type f of x equals x. So here's your first example. F of x, and I want you to type f of x in. Just type this. F parentheses x parentheses equals x into Desmos. It will do function notation for you. Type it in, and see what shape you get. What shape do you get? You can draw it in the air. Right? Something like this. Like that. Right? Okay, so now modify the function. Let's do another one. Make it f of x, and you can modify the one that's in there, or you can do a separate box. You know how we do separate boxes? Maybe do separate box, because you can turn them on and off. This one is 3x plus 2. If I can read my writing on the board. 3x plus 2. So type f of x. Everybody say f of x.
F of x.
That's how you say the function notation, that f parentheses x. Okay, are you doing it?
Right.
Doing it? I'm gonna over.
F of x.
Type this one in. I'm typing this one in. And if you keep them both open and you do a separate window, now you start to see what does the plus 2 do to this graph? Moves it up 2. 1, 2. Remember our whole discussion of how these graphs are moved by adjustments in the formula? So this one plus 2 is pretty simple. Moves it up plus 2. It goes up like this. This one is the slope, 3. Do you remember rise over run? So it goes up 1, 2, 3, and over 1. And there's another point here. And so it should be a steeper line, a lot like that. Am I close? Look at your graph on your screen. Is my line here close to yours? A little bit? Okay, and one more. Type in, open a new box, type in f of x equals 1/3 x minus 5. 1/3 x minus 5. And maybe before you type it, your brain is trying to think what will produce. Can you stop yourself a second and go, if I type in 1/3 x minus 5, can you make some predictions about what will graph? Because part of your challenge is have the computer show me what it does, right? Your other is, if I had to do it without if I could just have the computer teach me a little bit, and now I know what's going to be produced. Now you kind of get the idea. Yes, that looks good. So way down here it's crossing, right? It's crossing at 1, 2, 3, 4, 5 down through here. And it's got a slope of rise of 1, run of 1, 2, 3 over here. So something shallow like that. Is that close? And yours will do it different colors. These are examples of which one? Good. Good, good, good. Everybody say linear.
Linear.
I can say it that way too, though. Okay, that's correct too. Don't just because I'm saying it the other way, don't take away from the way you said it. Okay, so all linear examples, right? And I can say linear too. Okay, I get it. That's at least my brain knows what's in there, right? The word line. Got it. Okay, go to quadratic. Now let's graph some of those examples. So here's the first one. F of x, and I would open another box. Keep all your lines up there, and you might turn them off. Go to the box, the color right next to it, and click, click, click. It'll turn all those off. But they're still in there, and you can turn them back on at will, right? That's what I like about this. What's your simplest quadratic? Do you know? What's the simplest quadratic? Remember, your brain is shifting into quadratics now. How many multiplication steps does it take to produce a quadratic? Okay, so that's where the quad comes from. It takes 4 steps. What are you multiplying when you do those 4 steps? What are you multiplying when you do those 4 steps? Okay, I'm gonna warm you back up. I mean, do you see how every morning, like your brain is like, I gotta warm back up and go back in? Right, it's normal. Our brains always do that. And our brains are programmed, I think, naturally. If we don't use something regularly, we flush it. I mean, I maybe that's a crude example, using the word flush, but that's what our brain does. Can you imagine the amount of data that goes through your brain every day looking at your phone? It's massive, right? Thank goodness your brain flushes most of that. It's all a waste. It takes up space in there, right? It's like a computer that every night purges its own hard drive, right? It just goes, this is worth this, and that's worth this, and that's worth, and it's your brain's pretty good at it. In this case, I want you to remember this, but in general, your brain's pretty good at getting rid of all the stuff it doesn't use. Okay, so type this in. Type in x to the power 2. That's your most basic quadratic. That's the basic definition of a quadratic. Raised to the power 2. Okay, type that in. What shape you're going to get? Predict what shape you're going to get. And you can turn off your others if you want. See how you can click these colors right here if you want. And it cleans up. Balmer, are you doing it? Yes. Okay. All right, what shape did you get? You got something like this, right? And I wanted to make it touch right here because it literally touches right there at the vertex. The vertex of the parabola is touching the origin of the Cartesian coordinate graph at 0, 0. This is your most basic quadratic. So let's start to modify it and see what it does to the graph. And we already did some of these. What if we say do another box. What if we say f of x equals x squared plus 3? What's going to happen before you do it? What's going to happen? Now it's an x squared. This is x squared. Now it's an x squared plus 3. What's going to happen? I see somebody motioning. Motion with your hand. What's going to happen to the parabola? Okay, good. Good. I think good. Is that what's going to happen to the parabola if it's plus 3? Good. By how many? Everybody go. Right? I mean, now type it in and see if it does it. Right? Now type it in and make sure it does that. Right? That's how you test your brain, and that's how you can learn a lot of this stuff without a teacher. Right? You can just use the device to just type in a bunch of examples, and what's going to happen is next year you're going to forget. Right? You're going to forget what all these are, but just open Desmos and start to type them in, and then your brain can go, oh yeah. Right? It's not. Once I see the examples, my brain can just pick it up again. All right, and one more. Let's do a third one. What do I give you? Oh, I give you an interesting one. I give you f of x equals x plus 3, x plus 5. F of x equals parentheses x plus 3 parentheses x plus 5. What's this called right here? It's a binomial. Everybody say binomial. This is what one binomial times another. This is where the 4 multiplication steps come from. Okay, and where does this parabola cross the x-axis? Look at your graph on your screen and look at the board. You might be able to predict it from the board where that parabola is crossing the x-axis. So yeah, type a whole f of x equals. Type it again. Parentheses x equals. And then do the parentheses x minus 3, x minus 5. Good. And can you focus in, see where it's crossing the x? Can you focus in on that? So mine on the board are pluses. You changed yours to minuses. I just want you to look at, see which way did yours shift? Yours went to the right. Did you see that? Now when you change it to this, it goes to the left. Does that make sense to you, given that these were pluses and the others were minuses? It does? Because the plus is to the right and the minus to the left. You know what I'm saying? Okay. It's actually backwards if you think about it. It actually goes backwards. Okay. And let's do the 4 steps. X times x is x squared. Outside, plus 5x. Inside, plus 3x. And last, 3 times 5 is plus 15. X squared plus 8x plus 15. That's our 4 multiplication steps. In a separate box, type f of x equals this. Is it going to be different than this one? Interesting. I got a couple of different answers. So graph it and see what happens. All right, so can I start to summarize for the linear? I'm going to do this. I'm going to do just a generic line, okay, for linear. It's a line graph, generic. For the quadratic, I'm going to do a generic parabola, all right, just to kind of summarize what we've got here. Let's go to exponential now. Oh, by the way, is it the same or not? Yeah, actually, it's the same. And does that make sense to you? We took the problem and just multiplied it. I hope it's the same because all the numbers are in there, right? All the variables and numbers are part of that. Just because we multiplied it doesn't change, the whole setup of what we're dealing with. This is a little bit off topic, so I'll skip it. Let's go straight to the exponential. So here we've got a graph. Let's start to graph f of x, and here's the most generic exponential. What do I use? I use, 2 to the x, of course. So f of x equals 2 to the power x. Type that in. Type that in. Can you figure out how to do power and then put an x in for the power? 2 to the power x. So in this case, the variable's not down in the base. It's up in the superscript position. Yes. And what kind of graph is this? It looks something like this. This is what some of you mimicked with your finger when I said, what's exponential? You drew this. And this might go steeper. Actually, this might go like that. Right? Where is it headed? Straight to the moon and beyond, right? To infinity and beyond. I don't know if I'm allowed to say that, right? That's a copywritten phrase. But this is what's happening. Look, one person gets sick and gets 2 others sick, who get 2 others sick, who get 2 others sick each, right? You see where we're headed here. And so you have a living experience with this. The virus you've lived through is doing this. This is what happens when we have an outbreak. It's an exponential curve. And the Omicron variant, it didn't go 1 to 2. It went 1 to 10. So one person got it, 10 people got it. Each of those, 10, 10, 10, 10, 10, 10. So that one's going right? It could be slower. It could come up like this. Maybe it only spreads slower, right? And that's, then what stops, how does the virus ever stop? Why doesn't everybody die on Earth? Why don't we all die? A lot of us did, right? And still are right now, to this moment. Why didn't we all die? Well, didn't we start wearing masks? Didn't we all stay home? Didn't we all stay 6 feet apart? That stops this thing. That slows it down. You're trying to slow it, right? You're trying to get in the way of its spread, right? And those are the factors that lets it spread. So we did all those things, and some of them are even controversial. I don't know how much my mask kept out. Some of us got vaccinated. Some of us didn't. Some of us got sick and developed natural immunity. You with me? All those factors started to shrink this where this exponential curve wasn't as steep. So here's your first one. F of x equals 2 to the x. Do another. Open another box and do, let's play with it a little bit. Do 2 to the minus x. Make the x negative. Make the superscript x negative. And do you know what's going to happen? Can you predict how something's going to happen? Okay, go. You can turn off your other lines unless you like them all up there. I guess it looks kind of cool with them all at the same time. But you can turn them on and off. Okay, are you typing it in? Are you trying the power? Try to type to the power. Which way does that one go? Draw that with your finger. It goes like this. Right? Can you predict the next one? Type in the next one. This time it's a negative 2 to the x. What do you think is going to happen? This one went up. This one went down. What do you think is going to happen if now make this positive again, but make the base negative? Make the 2 negative. What's going to happen now? Predict and then graph. Predict and then graph. What did it do? Type it in real quickly. We've got one more after this, and then I got to finish before my announcements come up. Okay, who's graphed it? Natalie, did you get it? What, with your finger, show me what it does. One more time. Like this? Or like this? Yeah. This one here, right? It's coming down this way. This one? Yeah? Did I get it? And turn off, so you can turn off your others. Just leave the one on and see which one's remaining, right? Did I get it? Is this the right one? And then one more. Do f of x sorry to rush you, minus 2 to the minus x. Do negative on the base and negative on the power. And I think you're getting something like this now. And that'll round out. This should be passing through -1. This should be passing through 1. I'm getting really sloppy with my graphing, but your graph will show it passing through the y-axis at +1 and -1. And that's the way the exponential curve goes. Okay, let's summarize. So here's fill in the exponential. This is it here, up to the heavens, forever. All right, so vocabulary, linear, quadratic, exponential, and that's it.